Good afternoon. I'm Ann Aylward, Director of the U.S. DOT Volpe National Transportation Systems Center, and I'm delighted to welcome you to Up and Away, Innovations in Advanced Air Mobility. This is the second event in a series sponsored by the Volpe Center and the FAA. Today, we are delighted to welcome Derek Morgan, Chief Operations Manager, Aircraft Certification, Aviation Safety at FAA, and three speakers from the AAM industry: Cindy Comer, Director of Certification and Safety Management Systems at WISC; Eric Allison, Head of Product at Joby Aviation; and Blaine Newton, Chief Operating Officer of Beta Technologies. Thank you for being with us today. After our three speakers from industry speak, we will have a question and answer period. So please type your questions for the speakers in the Q&A box, and I'll get to as many of them as I can at the end of the session. We had a great kickoff last week with perspectives being shared by US DOT leadership and our guest speaker, Alon Head from the Air Current. If you missed the event, you will find the recap on our website. It's now my pleasure to introduce Derek Morgan as our first speaker. At FAA, Derek is principally focused on advancing organizational improvement through strategic engagement initiatives, including those aimed at new entrants. He currently leads the FAA Innovate 28 certification I-team and is supporting the Advanced Air Mobility Interagency Working Group. Derek, the floor is yours.
And what an honor to participate in this wonderful series that Volpe is co-sponsoring with the FAA. And on behalf of Associate Administrator for Aviation Safety, David Bolter, and Deputy Administrator Jody Baker, thank you, Ann, and the whole team for organizing such an informative and insightful event. Like I imagine so many of you all, the participants here in this forum, I made my aviation career choice through an abundant curiosity of flight and the science and technology behind it. I've had several opportunities over my 25 years in the industry to experience a wide variety of interesting things, lots of fun, exciting activities, and a few of them, some colleagues have said, were once in a career type opportunities. It was a little difficult to sense that while in the throes of a challenge, making small progress over days, months, and years until one day you're done. This overwhelmingly daunting ambition you start out with, usually through a unity of effort and concerted dedication by a bunch of people, becomes a realized achievement. But I suppose that's just the nature of progress. For over half a century, the FAA and the Department of Transportation have been at the forefront of progress in aviation safety. And today, in partnership with a mature, safety-minded industry, we've realized the safest era in U.S. air carrier operations. So while we've optimized our aviation system for the current types of aircraft and operations we see when we go to the airport, we're continually seeking and introducing more improvements. Turns out the public demands it, and our mission certainly calls for it. The FAA's 45,000 employees relentlessly pursue safety every day to assure the American people experience the world's safest, most efficient aerospace system. Today, however, we have new partners in safety. That progress has resulted in technological advancements to reveal an all-new manner of air transportation. Advanced air mobility in all its various forms, from powered lift, electric vertical takeoff and landing aircraft, to fixed wing, conventional takeoff and landing aircraft, It represents a sea change in aviation. You've probably heard others characterize it as truly transformative. And that's certainly what it looks like. The advent of AAM, Advanced Air Mobility, comes at a time when safety expectations are high, and safety system modernization is well afoot. And with the new integration challenges that AAM brings, such as how crew will be trained and where they'll take off and land, come a bunch of new opportunities to make all of aviation safer, more efficient, and more modern. I happen to be spending some time this week with colleagues from the Department of Transportation's Advanced Air Mobility Interagency Working Group. And we're learning about how new research in meteorology could aid in closing a gap in AAM flight planning, adverse weather conditions, for example. We also heard from a community consortium about how technology common between some AAM aircraft and new automated vehicles for agricultural use may create new workforce development opportunities. It's an interesting multimodal intersection. Just one example of the opportunities that we're starting to see become apparent in the AAM space. This afternoon, we're continuing efforts to develop a national strategy to safely integrate AAM into the national airspace system. And next year, after the working group's task is complete, the Department of Transportation will deliver its recommendations. Even before the longer range strategy materializes, to assure we're positioned to enable initial near-term AAM operations, the FAA has developed an agency-wide integrated approach. We call it Innovate 28. It's led by our Office of Next Gen. And Innovate 28 is comprised of members from across the entire FAA, bringing together expertise and experience in an innovative and cross-collaborative manner. While our certification teams perform their critical foundational work with some of the early players in this space, the broader Innovate 28 team also works collaboratively with companies making early progress in this sector to raise awareness of issues and take necessary actions in time to support the company's plans. As many of you know, companies have ambitious plans, high expectations to operate as early as 2025 and maybe begin revenue type service shortly thereafter. So we've established a strong rapport with several companies who've no prior experience working with the FAA, let alone bringing an unconventional certified aircraft to market. It's a tall order. So having strong relationships with them is essential to our collective success. And as a member of the Innovate 28 team, I'm pleased to say the work's paying off. Let me add, though, that it's not just this Innovate 28 team doing work. In fact, most of the work in support of AAM integration is being performed daily by the same FAA workforce responsible for maintaining the safety of the existing fleet and infrastructure. That, too, is a tall order, and I certainly commend them. I mentioned before that while I'd experienced career-shaping activities, their significance wasn't necessarily apparent while I was doing the work. My experience with AAM is markedly different. Every time I have a new interaction with the companies, their products, our staff who are down in the trenches putting together policy based on what they're seeing or someone's estimation of these innovations byproducts, I kid you not, I am simply amazed at how large scale innovation unfolds. This is pretty exciting. What a privilege it is to be a part of a new era in aviation, and for it to be one fortified with all that comes with the safest period in aviation's history. I anticipate that our esteemed AAM industry panelists share a similar sentiment. Their innovations have certainly piqued my interest and reignited that vibrant curiosity I had as a kid, captivated by the science of flight. I'm both grateful and congratulatory for their contributions toward the promise of what stands to be a transformative change and how the world more adeptly moves people and property. I want to thank you all for your time and attention, and I hope you all have an enlightening experience during the panel on safety and advanced air mobility. Thank you.
Thank you, Derek. It's now my pleasure to introduce Cindy Comer, Director of Certification and Safety Management System at WISC. Cindy is responsible for overseeing WISC's certification program and efforts, including aircraft production and operational certification, as well as ensuring WISC's safety management system safety management system gets deployed effectively across the organization. Cindy, over to you.
Thank you very much. And thank you, Derek, for those comments. I can say confidently that I feel very, very similar. I'm sure many people here do. So I'm going to tell you a little bit about WISC today. If you could go to the next slide, please. WISC is a company of about 700 people. Most of those people are in our engineering, manufacturing, and flight test teams. We have locations in the US, New Zealand, Canada, and Australia. We have over 240 patents issued, and we've done over 1,700 flight tests on our full-scale sized aircraft. We are backed by Boeing. Actually, as of the middle of this year, in 2023, we became a wholly owned subsidiary of Boeing. Next slide. We are currently working on our 6th generation aircraft. It will have 4 seats. Our goal is to roll this aircraft out for passenger carriage for commercial service. And these will be for short hop type of flights. We do not have a pilot in our aircraft, so this aircraft is autonomous, and it does have human oversight, which I'll talk a little bit more about in a minute here. Next slide. Something that I think is probably on everybody's mind, as it is every day at WISC, is safety. Safety is our absolute first priority. We are designing our aircraft to meet and exceed, in some places, the highest possible aviation standards of safety. We partner with the FAA and other regulators as well to talk about advancing safety in this industry, but also about how we are going to ensure that our aircraft is safe. Ultimately, the FAA and other regulators are going to determine the appropriate safety standard for this new type of transportation. And we fully support the FAA's safety continuum. And we are committed to meeting and exceeding these safety standards in as many places as possible. We are, like I mentioned, we do not have a pilot in our aircraft, but we do have human oversight for the autonomous aircraft. That human is on the ground. We call that person a multi-vehicle supervisor. And that person is capable of commanding the aircraft, but not controlling the aircraft. So they have limited abilities to command that aircraft. And we will continue to combine that automation that's on aircraft today with the next step in automation that we are bringing forward. We have targeted a simplified design, and in every case that we can, we make sure that there is no single point of failure. Absolutely, in any safety critical parts of our system, there is no single point of failure. And we're working on redundancy in every place that we need it. If you go to the next slide, I have a video to show you.
At Whisk, our planes fly themselves. And while there isn't a pilot on board, all flights are monitored by a ground-based supervisor. To achieve this new self-flying first approach, we test our autonomous technology in both simulated and real-world environments. Through a multi-testing process, we refine our self-flying technology and work hand-in-hand with regulators throughout. To start, we run extensive digital simulations of our entire system and its environment, including the Fleet Operations Center, multiple Gen 6 air taxis, other air traffic, and weather. This enables thorough testing of real-life situations without risking safety. It ensures the technology works before we put our air taxi in the air. In parallel with our simulation efforts, we also test our technology and capabilities by using other certified aircraft or surrogates like helicopters. We use simulation and test flights to improve the technology by continually exposing the system to new scenarios, collecting data, and refining the system. Data from external providers and air traffic control is also incorporated. After completing extensive testing on the surrogate helicopter and simulation, the hardware and software is safe and ready to be integrated into the Whisk air taxi. We then prove and demonstrate the air taxi and system to regulators. With their approval, our fully certified air taxi can begin safely transporting our customers. The third element of our testing are integration labs, where we study and help minimize the operator workload, develop training requirements, and allow all parts of the system to interact: the people, ground systems, and air taxi. Through this extensive testing and our partnership with regulators, our self-flying air taxis will be a reality within the next few years.
Thank you. So I wanted to talk a little bit more about our certification and some of the activities that we're doing there. We are certifying our Gen 6 aircraft as a Part 23 aircraft. In that aircraft, we actually consider it a system, is our ground control station. And so that we are bringing into our type certification efforts in Part 23 as well. We are working to certify our production system as we get ramped up for producing all of these aircraft. And we're, like I mentioned, we're rolling out for commercial operations with this aircraft. And so we will be obtaining our Part 135 certificate as well. Through all of these activities, we are working with the FAA on how do we define certain roles like that multi-vehicle supervisor, and what role do they play in the ecosystem that we have here, and how does that relate to the traditional aviation system today, and other crew qualifications, because there are going to be different crew associated with this aircraft than would be with a traditional fixed wing aircraft. So we are defining those processes, we're proposing things to the FAA, and we're working with them on how that's going to look as we move forward. As I want to bring the last bit here back to safety, like Derek mentioned when he was speaking, something that is very important to Whisk is that when a passenger steps on board one of these aircraft, that they can expect the same level of safety that they would expect if they got into a commercial aircraft. And so everything that we do with the new technology that we're bringing forward, this new approach, is that we plan to meet all of the safety standards, all of the regulations that apply, and build that to the same standards that a traditional aircraft would be built. Thank you very much.
Thank you, Cindy, and thank you for that video. It's now my pleasure to welcome Eric Allison. Eric serves as Joby Aviation's head of product and most recently led the Elevate team at Uber, developing software tools that built on more than a decade of experience enabling on-demand mobility. Eric, you're up next.
All right, can you see my screen?
Yes.
All right, so Great to be here today. I'm very excited to talk to all of you. I'm going to start a little bit by talking about Joby, what it is that we're doing and why we're doing it. So AAM is a broad term that captures a number of different types of activities. We're really focused on maybe the original form of AAM, which is UAM, urban air mobility, or more specifically, the air taxi market. So the basic idea that we care about is saving people time. When I worked at Uber, as I was just described, I live about here in Silicon Valley, and my office where I had to go every day was up here in San Francisco. And this drive is about 37 miles, and I did it every day, or nearly every day. And it took me something like an hour and a half, which is kind of crazy, especially given what we know now about our ability to be flexible post-pandemic and the way we work. And not just that I do it every day, but I did it both ways, right? You have to go home at night. And it's really a phenomenal amount of time, if we think about it, that we spend sitting in traffic on a daily basis. And that motivation is really what Joby is after for the product that we're bringing to market, which is not just an air taxi, but the overall air taxi service that we're going to be offering to people in major cities all over the world. And we know that this problem is not getting better, that some significant portion of the world population lives in mega cities and in these large population centers that are getting more dense, not less dense. And so if you look at just the San Francisco area here in California, where we are based, it's something like in 2019, 360 million hours per year were people sitting in traffic, time that they're not with their families, not being productive, not doing the things that they want to do. If you look at the top 10 cities in the US, that's something like 4.6 billion wasted hours. So the opportunity to save people time and make their lives better is pretty immense. And that's not even looking at the environmental cost and environmental opportunity as well. We know we can't build a way out of it. Latest figures, $250 million per mile of highway that we want to add, because where people want to go is where there's stuff. We can't tear down buildings. It's incredibly expensive to add more ground infrastructure. And of course, 29% of global emissions is accountable for transportation. So we think that there's an opportunity with this new set of technologies that we've been working on for over 10 years, that others have been working on to really make a difference in this, and to take advantage of that same capability that has made cities incredibly productive as economic loci in the world. So that if we go through the air and when we can fly, take advantage of the third dimension, it's not just an hour and a half that I need to spend going to work, but I could maybe do it in 15 minutes. And that's really the promise of the air taxi mission that we are focused on. So how does this actually work? So basically, if you think about it, at any time, essentially there are lots of people looking for rides in an app like Uber. And so Uber is one of our major partners. If you look at a place like JFK, where people are going to the airport, and the idea is that we can actually look at that demand and we can aggregate that demand together into a trip that people actually want to take. So there's like these eyeballs, we call it top of the funnel, where people are looking at, I want to take a trip to JFK. And at the same time, lots and lots of people are looking at that. So if we can put them together and bring together that demand, we can actually make this economically viable and make it something that is really, really useful for people on a regular basis. And by taking advantage of that kind of aggregate demand and the way that people are using technology right now to do things like go to the airport. So with partners like Uber, partners like Delta, we can connect this together, and we actually can provide this valuable and near-term, very, very useful service for people. And we know that something like 29 million trips per day are being taken in a region like New York, and most of them are short range. Most of them are of that nature, less than 50 miles. And so the opportunity for this space is absolutely immense. And we can make people's lives better across regions like New York City, across the world. So Joby is focused on building not just the aircraft, but the overall service to make this possible. But of course, you can't build a service if you don't have the aircraft. So we've been working on this aircraft, this concept of the aircraft for well over a decade. We were founded in 2009, first flew full-scale aircraft in 2016, 2017. and have been flying this kind of refined version of the aircraft for a few years, well over 1,000 test flights that have really proven out the concept and the technology. It's a hex tilt rotor aircraft, actually more technically proper, a tilt propeller aircraft. There's only collective, not cyclic on the propellers, and essentially can take off and land vertically. But it can do it with a remarkably low noise signature that I'll get into a little bit more, that we think is really, really essential for making this overall market viable. So like I mentioned, we've been working on this for quite a while, and we just rolled out our production prototype earlier this year in June, and really driving toward FAA certification of the aircraft. And one of the features of the way we do things is vertical integration. I'm going to talk about that a little bit more in a second. But our broad view of this market, of this opportunity, has driven us to the right requirements for what this aircraft can do. So we think that there are certain characteristics that you really need in order to make a viable aircraft for the air taxi market. You got to have the right payload, the right range, the right speed, the right sound profile in order to access this immense demand that I just talked about. So we've designed an aircraft that's got 1,000 pounds of payload, 4 passengers plus a pilot. We think that's really important to drive the economics. We can offer trips up to 100 miles with this aircraft at up to 200 miles an hour, so we can save you time for where you want to go. And we can do it with this remarkably low noise signatures, so less than 45 dBA in cruise. So we take a vertically integrated approach to do this. So Joby is building most of these components and certifying most of these components ourselves. And by doing this, we can drive efficiency in our engineering. And efficient engineering means a more performant, lower weight, lower sound profile aircraft that we think is really essential to be able to bring this to market. And it makes us nimble and allows us to navigate the challenges of certification in an optimal way. We are building out our capabilities in Marina, California. This is where we have our production, or our pilot facility, where we are building out aircraft right now, exercising this prototype manufacturing line, where we'll get our production certificate. We announced earlier this year that we're building out a scaled manufacturing facility in Dayton, Ohio, the birthplace of aviation. And we're really excited about that. That's where we'll be building not just tens of aircraft per year, but hundreds of aircraft per year to serve this immense market. At the core of what we're doing is safety. So we are architecturally taking a system safety approach to how we design and build this aircraft. So, for example, we don't have single points of failure in our propulsion system, which for a vertical takeoff and landing aircraft is something that's pretty unusual. So the approach that we've taken to do this is we have dual wound motors. For example, every motor is actually 2 motors that are completely electrically independent of each other. We have isolated battery packs. The battery packs are hooked up to different battery packs, power the different sides of the dual wound motors, for example. So we have chains and layers of redundancy built into what we do, so that we have that goal, that priority of a safe and reliable aircraft at the very, very core, at the architecture of how we're putting these aircraft together and put them into the air. And we're doing all of this work ourselves. Again, we're vertically integrated, so we're building out, we're designing, we're testing, we're building these aircraft to make this possible in a very aggressive time frame. And I'll highlight just a little bit more of the technology here. So one of the benefits of this vertical integration is pretty unprecedented performance in our components. So for example, our motor, we have something like 236 kilowatts of peak power in a 28 kilogram package, which is really good from a power density standpoint, but from a torque density standpoint, which is where you actually can get low noise, we're pretty unprecedented. So we have, each of our motors has as much torque basically as an F-350. And this is what allows us to have a remarkably low noise signature. So electric doesn't get you low noise for free. You have to design it right to actually get to that acoustic signature. So we've done a bunch of work with NASA with the national campaign to validate our noise predictions and approach. We did a testing. This is a testing campaign from 21. We published some papers around this with the data and the results of this. Basically measured the performance over a microphone array, built an acoustic hemisphere from that, And then you can use that to put it into different environments where people really are sensitive to this type of a noise profile. So for example, in New York City, on that route that I mentioned, going from Manhattan to JFK and from JFK to Manhattan, if you look at the differences between a light helicopter with kind of a similar performance and a Joby aircraft, the acoustic footprint or the people affected by the noise profile of the aircraft is 100 times smaller for the Joby aircraft compared to a typical helicopter. And if you've been in Brooklyn and heard the noise of helicopters, you know that this is an issue. And this is something that we really care about. And another kind of like aspect of this is that you don't have the same type of idle noise with helicopters or with the Joby aircraft or with most eVTOL in general that you do with helicopters. And so we actually did a demonstration recently to show this. We did a flight in New York a couple weeks ago to kind of let people see this for themselves and start to experience and understand the opportunity that this technology brings to communities like New York, where they are very sensitive to the noise question, but the utility of aerial operations is incredibly obvious. Like there's a huge benefit to be had from this type of vehicle in that kind of a context. So we're really excited to have the mayor there and to really be able to show this to folks and what this means to them in their daily lives. We're driving through certification, so we've kind of laid out in our public communications the way we view certification and the 5 stages that we've laid out in terms of communicating all the things that have to happen. We're marching through it with the FAA to get to that point where we can actually be operating commercially. And we're doing it with a best-in-class set of partners. NASA, obviously, as I mentioned, the Air Force has provided great support through Agility Prime and really great industrial customer partners as well, with Toyota and Uber and Delta. We brought on SK Telecom as a partner earlier this year, as well as ANA and Signature. So we've got some really fantastic partners behind us to make this possible. And I'll end with this idea that we care about making people's lives better. So our goal, our North Star as a company is to connect people with the people and places that matter the most to them and make their lives better. And so we think of that lost time sitting in traffic as not just wasted time, but as truly missing time. And that's time that we can give you back. So we're excited to do it. And we're excited to take questions later on that. Thank you very much.
Thank you very much, Eric. And our last speaker before we move to the Q&A is Blaine Newton. As COO at Beta, Blaine leads the company's commercialization strategy and approach, ensuring the business is well supported to execute its ambition. So, Blaine, you're up next.
Wonderful. And timing was great here. So, Eric, we're here at the Burlington International Airport, the Leahy International Airport at Burlington. And the F-35s across the runway from us just launched, and they do not have the noise engineering you have. So appreciative for what you're bringing to the market. I think that, the most exciting thing for me here, listening to Cindy and Eric and Derek, is that there's so many different approaches and opportunities to, and there's the F-35s, and I apologize, timing, is the different approaches and opportunities afforded by this next generation in mobility, and it really is being driven by those propulsion systems. This picture is a fun one for me. We tend to use pictures of things that we are working on or have done, and what this picture represents, I think, sums up really how we approach aircraft design and overall operational safety. This is a picture of us flying out of into the airport, the airport at Cincinnati, which is a Class Bravo airport. It's a busy airport, and you realize real quick in that environment that you are at the mercy of air traffic control and not of the aircraft, right? You in an electric test aircraft. This is our serial number 1 proof of concept test aircraft that's flown hundreds and hundreds of flights. In fact, I think enough miles now with a pilot in it to fly around the earth and then some. Flying in real world conditions to test the systems becomes really important as you think about safety. And if you could move the slide ahead, that'd be wonderful. If you can move the slide, that'd be great. Yeah, and so talk a little bit about Beta, and I'll kind of intersperse how we think about safety throughout that. But we tend to be a fairly pragmatic group here. We're really focused on delivering a holistic set of capabilities to our partners and to the industry at large. You know, we have a slightly different model than Eric articulated, in that we're not building the service as well. We're really focused on building the aircraft and becoming an aerospace OEM. And with that, in partnering with UPS and United Therapeutics, and most recently announced Air New Zealand, we recognize the need to deliver not only incredibly safe, reliable aircraft. And, you know, when we were listening to excuse me, the folks speak earlier about the priority around safety, you know, we share that too. We're a company of aviators, but we know that to deliver a successful ecosystem, you need more than that. So we've also developed peer-reviewed industry standard charging infrastructure that is both interoperable, fully interoperable, and multimodal to support the missions that our customers will be flying. And then lastly, but certainly not least, because, you know, the technological safety and the technology and the safety and redundancy of the systems is critical, but we think equal to that, and what the FAA has been so good in the US air system is this holistic approach to safety that goes through not only the ground support equipment that Cindy was talking about and the ground stations, but also through pilot training. And so as you know, like I said, we're a culture of aviators. Everyone that works at Beta gets the opportunity to learn how to fly. Out of the 600 or so folks that work here, well over 400, including myself, are at some phase of getting their pilot's license. And that understanding of what it takes to take an aircraft off by yourself and land it safely, and everything that goes along with that, is pretty core and critical to how we think about developing this new revolution in mobility. It's core to how we think about the world. If you could move forward just one slide there. And, you know, we're also thinking about multiple forms of air mobility. You know, again, there's urban air mobility certainly is, as you heard from Eric, a massively viable market. And Cindy, the air taxi market is huge opportunity there. And we're excited about that market. But we also see an entry point into this space serving mission critical cargo, whether that cargo be human organs, and for supporting United Therapeutics' mission of an unlimited supply of human organs by the end of the decade, or moving custom critical cargo for UPS, or moving the mail for Air New Zealand. Those are all massively important missions that can benefit from the same safe, reliable, cost-effective, zero-emission, low noise profile systems that we're bringing to market. So we're certifying really 2 aircraft here, and we're making great progress on both, in large part because of the tremendous partnership that the FAA has brought to the table to work with us on tackling these new issues in aviation, whether they be fly-by-wire systems in a Part 23 aircraft, or electric propulsion, or more large-scale battery systems, and the redundancy involved in all of those. You know, like Eric talked about, we're also looking at dual wound motors in the pusher motor for our CTOL, and quad redundant systems in our vertical lift system. So no single point of failure across the aircraft. It's critically important. Being pilots ourselves, we understand that any critical point of failure is not a good day for the pilot or the folks on the ground. And so again, working closely with the FAA to drive that through. You know, we fly manned flight test every single day, multiple times a day, most in many cases, and we do this to test the systems. These are all manned flight tests, and they have been since we started on full-scale flight test with our initial tilt rotor aircraft back in 2017 that we retired in favor of these lift and cruise systems, which we believe, just from our perspective, are a more simple approach and ultimately more reliable approach to vertical takeoff and landing conventional aircraft. We've also had the distinct opportunity to fly with Air Force personnel, with Army personnel. In fact, Lieutenant Colonel Wes Ogden just recently had the opportunity to fly the aircraft for a second time, a year and a half removed from his first flight, and commented about kind of the continued evolution and improved reliability and safety margin and performance. And at the end of the day, as a pilot, you know that performance is some level, and performance is some level safety. And so, and then finally, the FAA and 2 of our customers, and taking pilots who have never been in an electric aircraft before, whether it be, again, from the military services or the FAA or a customer with Bristow and United Therapeutics, you have to think about what are you working to train on, and you're training on, the systems, right? So managing battery health and battery state of charge are different than managing fuel flow, although it can be very similar. And we're working on standards for that with Gamma as well. We take these pilots to the quality eval through a very, very robust ground school, just like we would take our own flight test pilots through. We simulate the flight tests in advanced simulation capabilities that we have, where the pilot's flying a simulator that mimics the aircraft. And then we take them up, with one of our flight test pilots in a dual control configuration, because as we're training, as our 35 flight instructors would tell you, that sitting with a trainee and working side by side with them to understand what will happen, what to expect when you do perform certain maneuvers on the aircraft is massively important as a way to safely train pilots and get them ready for real world working conditions. And so having the opportunity to take these pilots that are not beta employees very rapidly through a very robust, safe training program, we see as part of this overall safety ecosystem that will deliver a working, viable electric aircraft ecosystem into the market. If you could move forward one more slide, that'd be wonderful. As I said earlier, what we're also focused on a charging system. What good is a electric aircraft unless you have a network to go out and fly it on, and you can fly it wherever you want. We've been really, really fortunate to have customers embrace this standard in large part because of its multimodality, right? So you look at somebody like a UPS being able to charge their ground fleet and their air fleet from the same set of charging infrastructure that's been deployed. We've seen wide adoption with Gamma here of this peer-reviewed, internationally known standard that's being deployed, and we see this as a way to help this industry scale. We think it's massively important. We were able to fly, and on our way to Duke Field, as we flew down to the Air Force Base in northern Florida, we stopped along this charging network to exercise it and prove out its viability and prove that it worked. That was also a really cool opportunity for us to work through community engagement as we made these 21 stops, which turned out way more than we needed to get to Florida, but community engagement is part of this exercise. We learned a lot about public adoption and what people are looking for out of these types of systems. And noise is part of it, but safety and reliability is the biggest part. When can I put my family on that to fly across state and go see grandma? We stopped in Marshfield, Massachusetts, which is a small suburb on the South Shore, south of Boston. And it was a really fascinating opportunity because we're talking to the Northeast administrator of the FAA who came out to see us fly in, and she tapped me on the shoulder and made the comment, because that's interesting. And a public transit bus that was the first public electric transit bus in that county had pulled up to our ground side charger that's interconnected with the same equipment as our airside charger, and was charging their bus on that public service. So the opportunity to kind of electrify these communities and reconnect these communities to mission critical cargo, to rural health access, to just regional air mobility, and bring connectivity back in a way that was prohibitive because of cost before or noise before, and because the cost of electric aviation is so much lower than traditional aviation for a variety of factors, whether it be fuel or maintenance, you're able to kind of get into these communities and provide a service that hasn't been there in a long time in the form of, again, accessing that Z dimension of travel. We have 15 chargers in the ground now. We have another 60 plus in various stages of construction, and we'll continue to roll this out. Recently we had the opportunity to partner with Archer, who's working with us on our chargers to support their mission sets. And we just see this as a tremendous, a key critical part of the entire ecosystem, and safety. right? And so you think, why is the charge of safety? If I'm an IFR aircraft, which ours is, because we're supporting these big commercial working missions and operators that need to fly in all weather, and you can't land at a given airport because you need to go to a reserve, an alternate airport, and you're extending your reserves. What you don't want to have is variability in thinking, when I land at that airport, will I be able to receive fuel in the form of electrons? And so just eliminating, again, these barriers and allowing for safe commercial viable operation becomes critically important. If you could just move forward one more slide, please. And then lastly, and actually this slide's a little outdated. We've actually been in full-scale flight tests for almost 5 years now. It occurs to me. So, but again, the way we think about ensuring a safe system, like Joby, we're highly vertically integrated. We're building our own propulsion systems, these high torque density, high power density power systems that will enable this revolution in aviation. The battery systems to allow safe, reliable use in batteries with redundancy built in, and we're flight testing on them. You know, we fly manned flight test. Like I said, every day we've been able to have the opportunity to fly under this market survey airworthiness certificate with the FAA for a long time, out to Louisville and back out to Bentonville, now down to Duke Field. We actually we're thrilled to be able to fly through the Washington DC flight restricted zone when we launched out of Andrews Air Force Base recently. Again, which is a testament to our team, but also a testament to the partnership that we have with the FAA, who are evaluating the safety of this aircraft every time we fly to ensure that that market survey certificate, airworthiness certificate, should be allowed because it gets into safe flight. Another thing that we did recently that's actually not on here, but again, I think gets to, we view this industry in its nascent stage as a place where we're going to need to focus on collaboration, whether it be in charging standards or state of health and state of charge monitoring and batteries, or just creating the analytical models that allow the FAA to reliably certify safe product. So about a year ago, maybe a little longer, we took a full-scale battery pack out to Wichita with NIAR, the National Institute for Aerospace Research, and FAA in collaboration, and we did a 50-foot drop test. And we dropped that battery pack to see what would happen, right? And really to validate the analytical models that showed when you drop a battery from 50 feet, which is kind of equivalent to a helicopter drop test, how does it respond? And what we were able to prove out is that our analytical models were accurately predicted what would happen. And we shared those models with both NIAR and the FAA just to continue to improve the industry. And look, that's what we're excited about is there's multiple mission sets to serve here. There's multiple opportunities to improve and move towards a mission of decarbonized aviation, whether it's through autonomous air taxi or the great work that Joby's doing in urban air mobility. And we're just thrilled to continue to push forward, very much aligned with the FAA's goals of maintaining the safest airspace in the world.
Thank you very much, Blaine. Great presentation. And the noise of the jets going overhead was a very nice touch. We have more than 40 really excellent questions and only about 10 minutes left in the session. So given that today's focus is safety, I'm going to start with safety questions. For all of you, can you speak about how safety culture is part of your SMS? How do you ensure a positive safety culture in your organization? And is there space for external feedback? Cindy, do you want to take a crack at that first?
Sure, thank you. Yeah, safety culture is something that's very important to us. All of our mottos, and you'll see our mission is safe everyday flight for everyone. We talk about safety every day in every meeting. We celebrate our safety wins, and we understand when we have safety items that come up, why they've occurred. Something that's very important to us is a just culture in our safety culture, so that we are ensuring that our safety system is robust, and that we have ensured the proper training and the proper processes for people to follow, and not blaming accidents on people themselves. And so that's something that we live every day. And even as we demonstrated flights at Oshkosh and in Long Beach this year, our CEO, Brian Yuko, was out there every single day saying, if it's not ready to go, we're not going to fly it, even if, you know, like this is the biggest moment of our lives, but we're not going to fly it if it's not safe. And so that's something that you'll hear echoed throughout WISC.
Blaine or Eric?
Yeah, happy to jump in. Very similar philosophy. We're building an enterprise-wide safety management system that encompasses both our, the core design and manufacturing organization, as well as extending into our aviation operations. So we already have our Part 135 certificate that we got a couple of years ago, actually, and we've been exercising that and building out all of the processes around that to make sure we connect through our SMS, that air operations piece, with the rest of the core organization. So this is really fundamental to what we're doing. We decided to make an investment on it pretty early, actually, and have been building it out aggressively.
Yeah, not much to add there, because you're talking to two phenomenal companies doing amazing things, and we're very similar in our approach to that kind of universal safety management system. I think one of the things that I've noticed with us in particular, and I can't speak to others, but we have a really disproportionately high number of active and former military, with a heavy concentration in Air Force, sharing the base across the runway. It tends to be a natural feeder for really capable folks. And there's a culture in that organization of, when there is an incident on the flight line or an incident during a flight, it's immediately brought up and shared, right? It's failing loudly. So the lessons learned are shared almost instantaneously. And that culture hit us early with our employee flight training. As somebody, makes a hard landing or something like that, comes in and shares lessons learned to the entire company at one of our 3 times a week all company stand-ups. And that kind of early willingness to share without fear of retribution has kind of permeated the rest of the business, whether it be in manufacturing or elsewhere, or engineering. And so, it is this, Cindy, you talked about it well, it's this culture of openness that you're allowed to share what has happened in the spirit of everyone getting better. And you do that real time and rapidly, and you celebrate it at some level. And I think, to me, that's pretty critical. And it sounds like Eric and Cindy are experiencing some of the same things. And to do this right, you have to be willing to share failure.
Thank you, all 3 of you. The question now for Eric and Cindy. How do WISC and Joby ensure their battery safety, especially in terms of the occurrence of thermal runaway? According to the FAA, their battery fires on aircraft being reported almost once a week.
So happy to go first on this. I mean, so this is part of the certification process. So the standard that the FAA uses is the DO-311A, an extremely rigorous standard around battery safety. And then there's also additional requirements beyond that, like the 50-foot drop tests that Blaine mentioned, that are far beyond. That we have a lot of folks from Tesla that are leading a lot of the powertrain and battery engineering work that we're doing. And when we start to dig in on the requirements from the safety side that the FAA has laid out for certification of battery systems, they're like, whoa, right? I mean, that's it's next level when it comes to that. And so you have to do really, really good engineering to make sure that you are living up to those standards. And there's a little clip in that, I don't know if you caught it in when I was talking of that 50-foot drop test that we're doing with our modules that we have to pass in order to get certified.
Yeah, exactly what Eric said. There's tests that we have to pass in order to certify our aircraft, and we're doing all of the same things. We're doing additional testing in our labs to understand when a thermal runaway does occur, how does it vent throughout the aircraft, how fast does it propagate? So things that'll help inform us and help provide safety information to the FAA and industry as we get there. But yeah, we're following all the standards and guidance as we work through the certification process.
Yeah, just a quick anecdote to both of those. The question wasn't for me, but I'm sitting in the production center we recently opened up, and before we got the certificate of occupancy, we were sitting with the fire marshal, and we walked through the entire building with the fire marshal, and we're not required to have sprinkler systems over our battery manufacturing line, but we're required to have sprinkler systems in our bike storage because of electric bikes and scooters catching on fire, right? So these aircraft batteries are highly engineered systems with all of the safety factors that you could possibly imagine and more in there. And then the testing that they go through is absolutely rigorous. We you know, whether it's destruction testing, vibration testing, thermal runaway test, like it's very different from the types of devices and the electric suit or the smart suitcases that are catching on fire in aircraft that are just slapping a battery. And these are highly engineered systems.
Thank you for adding that. So I think we have time for one last question, maybe two. One concern in using pilotless AAM vehicles is the risk of cybersecurity attacks or spectrum outages of various sorts. In such an event, what happens? What's the fail-safe mode of these vehicles?
I'm going to assume that one's for me. So we spend a lot of time talking about cybersecurity. We are following cybersecurity guidance and working with the FAA to define what cybersecurity standards, in addition to that guidance, need to be met. How do we ensure that it's actually secure? And so if we were to have an incident where something were to happen in the connection to the aircraft has everything on board that it needs to get to a safe landing. And so we would default to the flight plan that's in there, and the link between the ground and the aircraft would be severed, but we wouldn't be worried about changing that flight plan. That's already programmed in there.
Thank you for that. You have all spoken regarding the safety associated with aircraft and in flight. What are some of the new safety concerns regarding the ground locations and the needed ground systems to support these types of vehicles and flights?
So I can jump in on that. I mean, you have to think about this as a system overall, and so it's not just a vehicle isolated or just a skyport isolated, but rather it's a system. And I think architecturally, one of the great things about electric aviation is that, again, the same kind of architectural considerations around building multiply layered redundancies into the vehicle itself in terms of how does the vehicle function. And the very nature of electric propulsion and kind of the technologies associated with that are conducive to safety on the skyport side of things as well, though. So we think that that's a very important consideration, that when you think about the overall, the safety enhancements of not having liquid fuel, for example, on a skyport, we think that that's something that actually contributes significantly to the overall kind of safety stance of that ground infrastructure side of things, as well as not having aircraft that require idling. You don't have to hot load like you do with a helicopter. If you go take Blade or one of the other helicopter operators in New York City, they hot load, and that's fine if you do it right. It's safe, but there are certainly, it's not as safe as if it was not spinning the rotor, and so those types of considerations are just different architecturally because of what distributed electric propulsion basically brings to the table and how electric motors work. Now, there's other safety considerations that you have to consider, in terms of the overall way the airplane operates. So you still have to plan and actually lay out what is the safety stance for ground infrastructure and make sure you're following that. But it's again, the nature of the technology gives us new things to work with to make things overall systems, the skyport plus the aircraft, that are, I think, going to really enhance overall safety in these types of operations.
Thank you, Eric. And with that, I'm afraid I need to bring this to a close just to be respectful of people's time. But thank you all for, excuse me, taking time out of your busy day to join us. Our next event will be held on Tuesday, December 19th, also at 1 p.m. Eastern Time. The theme will be Transformation and an Urban Air Mobility Concept of Operation. The featured speakers will be Paul Fontaine of the FAA, Steve Bradford, FAA Acting Assistant Administrator for NextGen, Steve Bradford, Chief Scientific and Technical Advisor for Architecture and NextGen Air Transportation System Development, and Robert Pierce, Associate Administrator for Aeronautics Research. Mission Directorate at NASA. We look forward to seeing you then and have a great afternoon. Again, thanks to our
Thank you
staff.
so much.
Thank you. Have a great day.
Thank you.
And thank you all for great questions.